Take a look real quick at number 11 in section 3.4. We're to find the value of the acceleration of the object given its position function at t, which will be the time here, when the time t is 12 seconds. Little s means for seconds, and not to be confused with the name of the function, which is s. They often use s for the position function. So s of t is this polynomial function. And they say give your answers a whole number. So they're looking for not a decimal approximation, or shouldn't be a fraction. That's not a whole number. So we'll give you a little help. Now, important relationships we need to know: if our position is s of t, which is what we're given, the velocity is what? The rate of change of the position with respect to time. And therefore, the velocity is the derivative of the position function. So v of t would be the derivative of your position function. Then what's acceleration? Well, acceleration is the rate of change of velocity with respect to time. So the acceleration is going to be your derivative of your velocity, which is also the second derivative of your original position function. So this one's pretty easy in terms of taking a derivative, I hope by now. The velocity, let's get that first. The derivative of the position function, if I take the derivative by the power rule, 23 is a constant multiple. The derivative of t to the fifth is 5t to the fourth. I have 17 times what's the derivative of t cubed? 3t squared. And the derivative of negative 7t is negative 7. Derivative of 45 is 0. Go ahead and multiply 23 times 5 and 17 times 3, and there's my velocity function as a function of time. But we're asked for the acceleration, remember, so we've got one more to go, right? Acceleration is the second derivative of the position function, or the derivative of the velocity function. So I take the derivative again. Here I got 115, t to the fourth is 4t cubed by the power rule. 51 times derivative of t squared is 2t. Derivative of 7 is 0. Clean that up by multiplying out these numbers, and there's my acceleration as a function of time. Now I can evaluate at what he said, when t was 12 seconds. So what is the acceleration when t is 12? I simply plug in 12 for t, use my calculator to evaluate, and I get my acceleration. Now, they didn't give any units of distance with this particular problem. They don't have feet or meters or centimeters or inches or anything. They do have time in seconds. It's kind of unfortunate, but if this was in, say, feet, the distance was given in feet, then of course your velocity in that case would be given in terms of what? Feet per second, right? Rate of change of position with respect to time. What would units of acceleration be? Well, they'd be feet per second, or sometimes that's written as feet per second squared. Okay, so hopefully this makes sense on this one.